Hey, welcome back. In this video, we're going to talk about semantic kernel, what it is, why it matters, and some of the real world use cases where it really shines. And then I'll walk you through a couple of demos so you can see it in action. I first heard about semantic kernel a few years ago when it was announced at Microsoft Build, right when the stuff about AI agents were just coming out. So first, what is semantic kernel? It's an open source SDK from Microsoft that was first released in early 2023. And the whole point of it is to make it easier to build apps that combine large language models with your own code and your own data. So instead of stitching everything together by hand, semantic kernel gives you a framework to organize prompts, run functions, and connect to external services. So if you have heard of Pedantic AI, they have similar concepts as with other AI agents tools or SDKs out there. So let's go over some concepts first, and I have a few demos that I want to show you, starting with a very simple example down to a more practical one. Skills and functions. So the functions can either be asemantic, meaning that they are powered by prompts in a model, or a native one, which is your own code. And a skill is just a collection of functions that makes it simple to mix AI capabilities with traditional logic inside the same app. Another powerful piece is the planner. So the planner lets you give the AI a high-level goal, and it figures out the steps to achieve it. So for example, you could ask, summarize this report, and then send a calendar invite with the key takeaways. And then the planner automatically changes the right functions together, so you don't need to hard code every single possible workflow. Semantic kernel also includes memory, which means that you can store and recall information, whether it's embeddings for semantic search, or just keeping track of user context across multiple sessions. So it's what allows you to build AI agents that don't start from zero every single time, but can actually remember what happened before. So one of the newer features is router agents. They let you send a request to the right skill or to the right model automatically. So if a user asks about the calendar, the router sends it to the scheduling agent. So if they ask about analyze some text, it routes it to the language model. So this kind of intelligent routing is super useful when you're running multiple specialized agents in one system, plugins and connectors. So these lets you integrate with outside APIs in services like Microsoft Graph, Pinecone, OpenAI, Bing Search, or even your own APIs. So it's what takes semantic kernel beyond just generating text and into doing real-world tasks. So what's the different use cases for semantic kernel? And why would you want to use it? So a few good examples. So if you want to build an AI agent that can use both memory and plugins to help with scheduling or research or communication, you can also use it for automating business workflows, like taking in customers' questions, routing them to the right service, and also generating structured responses. Or even creating multi-agent systems where different specialized AIs handle different tasks and the router coordinates between them. So in short, semantic kernel is what helps you go from a single model prompt to a fully functional AI-powered app. So that's the big picture: skills, planner, memory, router agents, plugins, and some of the use cases where this really fits in. So now let's jump into a couple of demos so you can see how it works in practice. So before we dig into some code, let's explore the documentation real quick and just kind of understand semantic kernel and how everything fits as far as all the different components that it has. So the kernel, as we talked about, is the central orchestration engine. Basically, it's the entry point for executing the functions. It manages the services. It handles basically the overall workflow of your AI application. And it also has a built-in dependency injection, which allows you to inject and provide the services and plugins required to be used by the tool. So there's the services, which basically consisting of AI services such as chat completion, or it could be any other services such as logging. There's also the plugins, which basically a collection of related functions that can be registered with the kernel. Plugins organizes functionality into logical groups and can contain both the semantic and native function. So native function that you would write in the code. So there's some documentation here for dependency injection and how it works. So you create the builder, and then you can just plug in the different services as singleton here. So you get the lights plugin, and then you get the speakers plugin. So the plugin could be talking to Notion. So you have some functions related to working with the Notion API, for instance, or working with Google Docs. That could be a separate plugin altogether. And if you go to the next page, it talks about the connectors. and what type of connectors are available. The first ones here are the vectors connectors. We're going to go through the different connectors available to Semantic Kernel in a little bit. There's a bunch of connectors available out there that you can use, whether it's for Pinecone or for Vector Store. You also have access to Hugging Face, OpenAI. So all these different connectors that's available for you within Semantic Kernel. So we talked about functions and plugins already. Plugins are basically like containers for your functions. If you scroll down, so you're going to see that your classes, which you wrote in C# or .NET, Java, or Python, can be fed along with the prompt templates. So prompt templates is basically a combination of user input and the system prompt. The prompt templates include the user input and the system prompt message. It gets passed into the kernel plugins and then into the AI service or models. It then goes into a function called loop. Once it gets to the AI function called loop, it returns the output. So all the code that I'm going to be showcasing in this video is going to be inside of my GitHub account, which is going to be linked in the video description. For the demo today, you're going to need to install the .NET 9 SDK, which you can go to .net.microsoft.com, and then you can just download it for your operating system. So once you have it installed, we can proceed with the demo. I'm just going to open up JetBrains Writer. And the first thing I want to do is show you the first project that I added. And before I do that, I'm just going to go and show you the references, which library we're going to be using for this project. So the first two are going to be the Microsoft extensions configuration and then the configuration.json, which will allow us to pull the key value pairs from the app settings.json file. And then the next one would be the Microsoft Semantic Kernel connectors OpenAI. So there's like a bunch of connectors that's available out there if you search for Semantic Kernel. So if I do a Semantic Kernel search and then connectors, you can see all the available connectors out there, such as Elasticsearch. There's also Hugging Face, Olama, Google, Mistral. So there's like a bunch of different ones out there depending on what type of connectors you need. But for this particular demo, we're going to be using OpenAI. So we're going to have to supply it with the model and then the OpenAI key, which you can get from the OpenAI's website. So this is an example of what the app settings looks like. You're just going to have to populate the app settings.json with this JSON string, and then you're pretty much all set. So let's take a look at the project, the program.cs file, which is basically the starting point for the console application. So if you've never written a line of C# before, don't worry, I'm going to break it down into lines. So the first two lines are referencing the libraries that we're using for this project. To use the libraries, we need to reference the libraries on the top using the using statements. The next one is we're creating a configuration object, which will allow us to pull in configuration value from the app settings.json, and we're just going to go and build that. So once we have the configuration, we can tap into the key value pair, the OpenAI model, and then API key, which we've added into the app settings.json. So once we got the model and then the API key, we can now proceed and build the kernel. And then we're just going to pipe in the add OpenAI chat completion, which basically allows us to pass in the model and the API key, and then we can build that kernel. We can go ahead and invoke any function that we want within that kernel. We're just doing a bunch of console.write line just to output in the terminal. And then we're creating a while loop, which will allow us to pull in the user input. So we're going to be allowing the user to put in any prompt, and then we're just going to read that and then invoke the function from the kernel. So once we get the result, we're just going to throw it back in the terminal, and then that's kind of the loop. And then the loop just starts over again. So we're going to go and wait for the next input, which is going to happen to Lando, and it's going to go in repetition. So let's take a look at how this looks like. I'm going to switch to the first demo on the top, and then I'm just going to go and hit debug. And this is going to switch into the console, which will allow us to enter any input that we want. So what is the capital of France, for instance? And then AI responds with the capital of France is Paris. So this is, as simple as it gets as far as using the semantic kernel. So we're going to take a look at the next example that we have here in the solution. So for the second demo, we're almost doing the identical process where we're declaring the using statement on the top, we're creating the configuration. So all of that is the same, and we're creating the kernel. So the main difference here is from line 15 to line 27, where we're declaring a prompt here. So once we create a prompt, which includes the system prompt, which As you can see, your AI to-do list assistant convert the user input into a numbered to-do list. And then we're passing in the user input, which is inside of this curly braces, inside of this dollar in. So once we declare the prompt, we can create a function based off that. So we're going to be calling this create function for prompt, which we're going to be passing in this string with this format. So we're outputting console.write. What do you need help with? And then we're just going to grab the input from the user. So once we have the user, we're just going to do a kernel.invoke async. So we're going to be passing in the new kernel arguments with the input based on the user. And that input is going to be added inside of this curly braces. So it's going to be user and then whatever input the user has. So it's going to create the prompt with the system prompt and then the user input combined. And it's going to be invoking that. So let's take a look at this example and let's go execute it. I'm going to switch to the second demo and hit debug. And then in the console, it's asking for what do you need help with? I need help, let's say, organizing my clothes and buying some groceries. All right, so then now it outputs the to-do list. Here is your to-do list, organize clothes, and then buy groceries. So simple as that. I was able to use the user input and then create a to-do list off of that. So let's take a look at the third demo that I have for you today. So we're going to kick it up a notch and introduce a few concepts that we haven't discussed in the first two demos. So everything's the same here from line 16 up to the top, where we're creating the kernel and then we're passing in the model and then the API key. The next line is where we introduce the plugins. We're going to be adding a plugin based on the type of task plugin, and the plugin name is called task. So we're going to be using that here, and then we're going to be calling this class. So this class has a list of string, which is going to be used to maintain and keep track of the task in memory. The next thing is we have two functions, which is called add task. And then the second one is to show all tasks, which returns the task that's available on our list. So we have added an attribute for each one. We've added a kernel function with a description. So this is going to help LLM to determine which of these functions needs to be invoked. So for the first one, we're just going to say add a task to the list. And then for the next function, which is for the show task, we're just going to say show all the tasks in the list. Based on these two descriptions, the kernel is going to determine which of those tasks is going to be invoked based on the user input. So continuing here in the code, we are also introducing a couple of concepts here, which is the chat and the history. So we're calling the service for iChat completion, which is part of the Semantic Kernel chat completion library. So once we have declared the plugin, we're going to declare a chat and a history. So both of these are also new. So we're going to be using the iChat completion service to create a chat. And then we're going to create a history variable here to maintain the chat history. So we're going to keep track of the system message, the user input, as well as the response, so we can have a history of what the conversation is about. And then we're also adding a system message here as far as the history. So before we even get into the actual while loop, we're adding a system message here. You are a helpful task assistant. Use the available tools to add task or show task when appropriate. So based on the plugin that we have declared on the top for the task, we're telling AI that we have two available functions that you can choose from, and then you are a helpful task assistant. So the next one that we are introducing here is the settings. So this is based on the OpenAI prompt execution settings. We're setting the tool call behavior to auto invoke kernel function, so you can pick the right function based on the user's prompt. And then we're doing a constant write line as part of terminal output for type exit or press enter on empty line to quit. So we're introducing the while loop once again, and then we're going to be reading the user's input. So we're going to be checking if it's an exit or an empty string. We're just going to go and break out of the loop if he detects either one of those two types of values. Otherwise, we're just going to carry on. We're going to go and add the user input as part of the history. And then we're going to go and call this get chat message content async, which is part of the chat. So we're going to be passing in the history, the settings, and the kernel itself. And then we're going to get back response. So once we get back to response, we're going to be assigning it into this content, this response.content. Otherwise, if it's empty, we're just going to go ahead and assign it an empty string value. So once we have the response, we're just going to go and output everything in the terminal. And then lastly, we're just going to go and add the response to the history. And then it kind of goes over and over again. So let's take a look at how it looks like. And let me make sure that I'm on the right demo and then hit debug. All right, this is for the tasks. I want to wash the clothes, which is going to be invoking this function. So I added a breakpoint for the add task. So you can see here that it's adding. Currently the task doesn't have anything. So we're just going to add to the list of the string here. I'm going to remove the breakpoint and let it execute. So I'm going to switch back to the console. So AI responds with the task, wash the clothes has been added to your task list. And then I also want to record a video. Then AI responds with the task, record a video has been added to your list. So let's have it show us the list. Show the list task. And then it's going to execute the second function, which is show task. So if the task is 0, which we do have 2, it's going to say no task yet. Otherwise, it's just going to go and print out the list of tasks. So I'm just going to remove the breakpoint here and let it hit continue. And then AI responds with, here is your list of tasks with the list. So wash the clothes and then record a video. So the last example that I have for this video is a bit more complex, but it's going to put all the concepts together in this one single app. So we're going to be building a web scraper that extracts the content from a website and then takes that and passes it to LLM, summarize that article, and then adds it to Notion. So for this, we're going to need a Notion database. So I created a simple Notion page and added an articles database. So we're going to need to grab the database ID from this articles database that I have here. Another one that you're also going to need is the Notion integration API key. So you can add a new integration here inside of this notion.so /profile/integrations page. So you can just add a new integration and then pick your workspace, pick the internal type, and then we're going to hit save integration name. So it could be whatever. So I'm going to call it SK for Semantic Kernel, and I'm going to hit save. And then you can go to the configuration settings. So now from here, you can see the internal integration secret, which you're going to need to add into the app settings.json later on. Make sure that you have checked the capabilities here, the read content, update, and insert content. And then the user capabilities, I just leave it to default. And then for the access, making sure that you have access to certain pages. So I'm just going to select the page that I want to give it access to. So once we have that, it's going to go and update. So save the integration API key, and also to get the database ID from this database that we created here for the articles, you're just going to click on the view database here. And then from the URL, starting after the slash, you're going to see the database ID on the top, and then it goes until before that question mark begins and the V equals. So this is going to be the database ID that you need to supply in the application. So those are the two things that we're going to need to run this application. So what we're going to do is we can just grab any URL or article that we want to summarize, and it's just going to populate the database here with the summary and then the URL to the article. So I just want to quickly go back into Notion here, into this database. So when I added the articles database, it added a single column of name. So all I did was I added a couple of new columns here, one for the content, which is a type of text, and another one for source URL, which is a type of URL. So those are the only two changes that I added here inside of this Notion page, inside of this database. So let's take a look at the fourth example by going back to Writer. So let's take a look at this project. So first thing that you notice here, if you go to the app settings.json, which I have a app settings example here, so I don't reveal my API keys. But inside of this, we have in addition to OpenAI section, we also have introduced Notion and the web scraping settings for this project. So inside of Notion, this is where you're going to be setting, inside of this API token, this is where you're going to be setting the integration API key for your Notion to access the page in the database. And then this is where you're going to be setting the default database ID here inside of this property. And everything else is pretty much the same unless you renamed these three columns to something else. Otherwise, you can just leave it as is. So this is going to be the title property name would be name, content property name would be the content, and then source URL property name would be the source URL. And then the web scraping is going to be the agent or the configuration when we use the HTML agility pack later on. So looking at dependencies for this project, we're going to be referencing the Microsoft extensions configuration and then hosting. In addition to those two, we're also referencing the HTML agility pack, which will allow us to web scrape the page content. And then, as always, we're going to be referencing the semantic kernel from Microsoft. And we're also adding the Notion.net SDK. So you can pretty much use any SDK that you want. I happen to use Notion.net to be able to interact with Notion and add a new record into the database for my page. So instead of grabbing the string directly from the app settings configuration, we're just going to bind into a class so that we can refer to the properties value via the property name, such as the API key and the model, such as I have here. So that's for the API service config. So the Notion config is similar to how we have it in the app settings, and the same thing with the app's web scraping configuration. So this all matches what's inside of the app settings. So let's take a look at the program.cs. So it's slightly different from the previous examples that I've shown you before. In this case, we're binding the configuration sections. So the first one that I've showed you was the Notion configuration. The next one is the web scraping config, and then the API configuration. So we're assigning a class for each of those sections. And then once we have those assigned, we can just refer to each of those properties within for each class. So underneath here, if you go to line 32, we're extracting the AI config using the builder.configuration get section. And then we're providing the section name. And that's how we can pull the value from the app settings. So we're getting the AI config here. And then now we can grab the API key from this object. Similar to what before, but we're declaring the add open AI chat completion differently. We're adding it to the services. We're passing in, similar to how we had it before, where we're passing in the model ID and then the API key. And then later on, we can refer to open AI chat completion in our application anywhere. The next thing that we need to do here is we need to register the different plugins and services. So I think we talked about plugins before, where we create different plugins for each task. So a plugin can be called as part of the tool when using the kernel. The kernel can refer to any of these plugins depending on the task that's been given. So we have a web scraping plugin, which includes a task for extracting article content from a URL. It includes a single parameter for URL. It grabs the URL, and then it's just going to go and fetch the content for that URL. It creates a new document using the HTML agility pack, loads the HTML, and then removes certain elements or tags from that document. Once we have that, it's just going to go ahead and return the output from that HTML body. So that's going to be for the web scraping plugin. For the Notion plugin, includes a couple of functions here. The first one is for creating the notes. It includes 4 parameters, one for title, one for the content database ID, and the source URL. It also has a description of what it requires so that the LLM can identify what type of argument needs to be passed in. And then after that, we're going to be creating the page. So going into creation of the record inside of Notion, we're going to create properties, and then we're going to be setting the content property name as part of this. So this is going to be the content that we receive back from the chat completion. So we're going to be setting the properties based on the content property name. And then we're also setting the source URL. And then we're creating a page parameter, which we're setting the database and the various properties that we've set above. Once we have that, we're going to add a content as a simple paragraph. And then we're just going to return back the new page ID for the record. So the next line is we're adding a article summarizer service, which will pull in all these plugins together. So what this class does is it's going to pull the 2 plugins that we have declared prior, and we're going to be using it inside of this class. So when we call this summarize article to Notion async, it's going to require the article URL and the Notion database ID. And then from here, we can use those 2 plugins that we have declared prior in the program.cs. So the first thing is going to invoke this function, which is our extract article content, which we're going to be passing in the kernel arguments of URL, which is the article URL. And then for the content, we're just going to go and grab the content for that page once we receive it back from that class. And then the next thing is we're going to be invoking this function from this kernel, from this prompt. So similar to the previous example that we had where we have a system prompt here, you are an expert at creating concise, well-structured summary of articles. Please create a comprehensive summary of the following articles that includes a brief summary. So we're basically summarizing the contents of a web page. And here is the system prompt for it. So important, keep the entire summary under 2000 characters. And then we're adding this curly braces for article contents. So we're giving it the article content. And then here's the summary. So we're going to be passing it here. We're going to be invoking this asynchronously. And we're going to be passing in the summary function that we have defined here when we create the function from the prompt. And then for the arguments, we're passing in the article content, which is going to be injected as part of the article content here. So once we have the result, we can grab the result or the summary back from the summary result here by getting a value of string. The next thing that we're going to do is we're going to extract the title from the content. So we're just going to grab it based on this function where it's going to go through all the content and it's just going to grab the title of the article. And then lastly, you're just going to push all that information into Notion using this invoke async. We're going to be calling this plugin for creating note, which is part of the Notion plugin here when we create a note. So going back to the service, after it created a new page, once it's successful, it's going to return back a page ID, which we're going to be returning back to the caller. So which is here. When you run the application, all this code is going to run and it's going to create a summarizer service and it's going to pull the Notion configuration value. We're also performing the same thing where we're actually going to grab the input from the user. So we want the user to supply the article's URL, and then it's going to read and assign the article URL into this variable. So once we grab the URL, it's just going to call this summarize article to Notion with the article URL and the database ID that we received from the Notion configuration object. So once we have the article in place, it's just going to add the article into Notion's database. So let's just run this. So now we can just grab any article that we want. So I'm just going to grab the URL for this article. And we're just going to go back into Writer and execute this, making sure that we are on the demo 3 and we can debug this. From here, I'll go back into the console. So I'm just going to remove the breakpoint and I'll just let it continue. So going down to the console, enter the article URL to summarize, and I'm just going to paste the article that I want to create. So going back to Notion, so I don't have anything here in my database. So I'm just going to just hit enter and the app is going to completely run. So since we declared add console here, it added a little bit more logging in the terminal. So at the bottom, you can see here that the workflow successfully completed, and then it gave us the page ID for that new record, and then articles successfully summarized and saved to Notion. So we can go back into our Notion's page. As you can see, there's like a new entry in our articles database, and we can take a look at it. And inside of this content, you can see the overview of this page. This is like a summary of what is in this article. So you can take a look at the key points, the main conclusions, and the important quotes and statistics. So these were all added as part of the system prompt as how we want the output to look like. And then we also include the source URL. All right, let's do a quick recap of what we covered in this video. So we went over 4 types of implementation using Semantic Kernel. One thing that I want to include here is none of these projects include any sort of validation or sanitation for the data. You just want to make sure that when you implement something like this, you want to make sure that you sanitize the user's input, make sure that you're not passing in any malicious data into the LLM, into your code. So that's something that you need to keep in mind when you reference any of these projects. But we went over the 2 beginner types of project, and then went over a little bit more difficult project. And then the last one was more advanced workflow integration. I apologize if I went a little bit too fast, but here's the URL to my GitHub so where you can reference all these projects and take a look at it on your own. But that's all I have for this video. So if you like more of this type of content, please hit like and subscribe, and I'll see you guys on the next video.